Hello.
Hello, sir. Welcome, sir.
Um, Good evening. Good evening. Good evening.
We'll wait for
So we will
15
be
minutes.
starting at 6 o'clock, no?
Yes, sir. We'll start at 6 o'clock.
Okay, no problem.
Good evening. Good evening, participants. Good evening, sir. Shall we start?
Hello. Good evening.
Am
Am I audible?
Yes, sir. You are audible.
Okay. Okay. Thank you.
Okay, sir. Then we'll start. I'll just give a brief introduction and then we'll start, sir.
Yes.
So, good evening, participants. Today is our third day of faculty development program on sustainable engineering and carbon neutrality. Today, we have the resource person is Dr. K. Rajendran, Director, Institute of Climate Change Studies. So, I'll just read a brief introduction about the resource person. So, Dr. K. Rajendran, he is the Director of Institute of Climate Change Studies. CSIR, Fourth Paradigm Institute, Winton Road, Bangalore, and he is also the Professor, Academy of Scientific and Innovative Research. His area of expertise include high-resolution climate modeling, climate change projections and climate change impacts, dynamical prediction of Indian monsoon, dynamics of variability of Indian monsoons, convection cloud aerosol interactions, air-sea interactions, coupled ocean atmospheric modeling, and numerical weather prediction, physical initialization, data analysis of tropical weather and climate studies, and atmospheric systems. So he has completed his BSc Physics from Kerala University, Kerala, and MSc Meteorology with first rank from Cochin University of Science and Technology, Kerala, and MSc Engineering from Indian Institute of Science, Bangalore. Also PhD from CAOS, Center for Atmospheric and Oceanic Sciences, IAC, Bangalore. He has a variety of professional experience. He started as a research associate at IIC Bangalore and he served as a postdoctoral research fellow at Florida State University, USA. Also, PDF fellow at Meteorological Research Institute, Japan. Then he worked as a research scientist at Meteorological Research Institute, Japan. And also he served as the senior scientist at CSIR, mathematical specialization with mathematical modeling and computer simulations. He served as the principal scientist at CSIR, Bangalore, India. He is a visiting scientist at AESTO, Meteorological Research Institute, and visiting scientist at Research Institute, Japan, Meteorological Agency of JMA, Tsukuba, Japan. Also, he was the visiting scientist and at Meteorological Research Institute at Japan, visiting scientist. Then he served as the group coordinator. Currently, he is serving as the director, Institute of Climate Change Studies, Kottayam, Kerala. And he has received many awards, fellowships. To name that few, he has received research JSPS Research Fellowship, Ministry of Education on Sports and Science and Technology, Japan in 2002. He has awarded the Academic Excellence from IAC Bangalore. Also, he received Dr. N.K. Panikkar Memorial Prize from KISS at Cochin University of Science and Technology, Professor C.V. Kurian Endowment Prize from Cochin University of Science and Technology. And he has international collaborations with Meteorological Research Institute, Japan. Also from collaborations with Florida State University, Tallahassee, and Atmospheric and Ocean Research Institute, University of Tokyo, Japan, and National Center for Atmospheric Science, Department of Meteorology, University of Reading, UK. And he is serving as several granting aid projects as the principal investigator, and he has received guided more than 5 PhD students, and he has offered courses on tropical meteorology and monsoon under the PhD program of ACSIR. He is a reviewer of several journals related to the climate change studies and meteorological studies, atmospheric research, climate dynamics, environment research letters. And he has more than 50 plus publications in peer-reviewed research journals. and he has edited more than 6-7 book chapters, and he has scientific reports, technical reports published related to that meteorological science, climate change studies. So, with this brief introduction, I welcome Dr. K. Rajendran to this program. Welcome you, sir.
Thank you, Dr. Saibi. This was a very long introduction. Thanks for briefing out all the this one. Okay, so I just came to know that this is a faculty development program which you are organizing at TKM Engineering College, and I feel like most of the attendees are working at various colleges or all from TKM itself.
No, sir. We have participants from all over the India. Across the India, we have participants. Mumbai, all that Indian states, Gujarat, Ahmedabad, Kanpur, engineering colleges, all those across India.
Okay. So, good evening to all. It's a very nice thing. I can meet you all through online. Rather than it would have been better if it is a personal interaction, which because we are all belonging to old family, but nowadays this became a new normal that online meeting is very common. Okay, so let me, as Dr. Saibi was mentioned, my today's discussion topic is on climate change and the carbon neutrality. Okay. So I will go with my presentation. Shall I start with my presentation?
Yes, sir. You can load that.
Okay. So are you able to see my screen?
Yes, sir. It's visible.
Okay, and it is in the slideshow mode. Am I right?
Yes, sir. Yes, sir.
Okay, fine. Let us begin. As I mentioned, I will be giving a brief introduction about climate change and carbon neutrality, what I will be talking in the later part. But before going to actual climate change related topics, it is always better to understand the difference between weather and climate, because many many people, even the educated people, also I found started mixing up. But nowadays, most of them are familiar because the climate change is becoming very evident as well as real, and it is more loudly known to many people. That is why it may look very preliminary, but still I thought it should be better to touch upon that very fundamental definition. So let me just go to that as what is weather and what is climate. Weather is nothing but it is the instantaneous state of. Hello, are you able to hear me?
Sir, please.
Yeah. Okay. In between some sound came. Then I thought maybe I'm not able to hold it. Okay. So what I was trying to introduce is weather. Weather is nothing but the instantaneous state of the atmosphere. It is just like as you are in whichever part of our country, what you are feeling at present, that is represent weather in terms of the temperature or in terms of any other weather parameters like the wind speed or rainfall or sunshine, whatever weather variables. But that will be very instantaneous. That is called weather. But versus there is another term is climate. Climate, we all know that because we all be using this in our day-to-day communication as well. How the climate will be in your region or the other region. It is something like a long-term average. Okay. So as you know, the primary source of our all this weather and climate is the solar radiation, which is coming from sun, and also due to the inclination of our Earth, the axis, we get different climate. over the equator, over the tropical region, or over the polar zone, depending upon its basically the temperature and other the weather characteristics. Okay. But as I mentioned, climate is usually referred to as a large weather conditions. It is an average of many weather events averaged over a period of 30 years will contribute to climate. Okay, so for example, I am giving one picture here. Top panel is it is a weather observation at a particular station at Bombay. What you can see here is there is a blue line. Okay, the blue line is the day-to-day fluctuation of rainfall is plotted at the top, and wind at 850 means about 1.5 kilometer from the surface. Then there is a temperature observation at the bottom. You can see that there is a large fluctuation. If the blue line is fluctuating a lot, that is what is representing weather condition, because the instantaneous weather will change from one time to another very rapidly. Whereas if you do an average of something like a 30 year or 40 year every day. For example, January 1 correspond to 30 different Januaries of previous years. Then you plot, you will get a red curve. That is nothing but an average value of the temperature or rainfall or wind. So that is representing the climate. Okay, so now comes to the climate change. So for example, in this red curve, so here it is, you can see there is 2 years, starting from one particular year and another year. So if there is a change in the temperature, for example, here, what will happen? The mean climate, which will come up to something like a 300 Kelvin in this particular year, next year, it maybe next a couple of years, it may be slowly, it is going to a increasing trend. So over a period of 30 years, it will increase from 30 degrees to 32 degrees. That is why people say there is a 2 to 3 degrees or maybe 1.5 degrees of warming. So that is what is that change from the present day to a day after several years is what is generally represented as climate change. Okay, I just thought I will touch upon this. Maybe many of you may be knowing it. It may be very preliminary, but still I thought of mentioning it. And same way, I wanted to introduce one more aspect. That is, you all know that our Earth has five major climate system. So it starts with, let us start with the land. That is our biosphere. And then we do have a cryosphere in which the surface which is covered with either snow or ice will be the cryosphere. Then there is a lithosphere that is several kilometers down from our Earth's surface, which is the main source of any the earthquake or volcanic eruptions. So that is in the lithosphere. Then we do have about as you all know that even our high schools we studied that ocean is covering our Earth about 70%. So that is representing our hydrosphere. Then comes the entire envelope. The entire Earth is covered with an envelope of air, which is about around 0 to maybe hundreds of kilometers with varying density. That is from the atmosphere. So these five major components cover our Earth climate system. So any changes in one system is interacting with other, and the Earth climate system can change in totality. Okay, now we come to people who are now, what is WMO? That is World Meteorological Organization. They have identified several climate indicators. Climate indicators means certain variables which will be representing over a period of longer time for the climate. For example, let us see in each sphere, what are all these? For example, if you want to represent temperature and energy, we generally define the global climate indicator as surface temperature. And if it is on the land, if it is over the ocean, there is another indicator which is called ocean heat, because the ocean, the specific heat capacity of the land or the solid and water, which you all know that, is totally different. So the ocean can store heat in abundance. So the heat capacity of ocean is much larger. So it can be a big storage of heat, which can be later supplied to the interface, that is atmosphere. So that is why ocean heat is one of the indicator. Then comes you all might have heard about the CO2, atmospheric CO2, that is the carbon dioxide which is existing in our atmosphere. And for example, there is an ocean and water, which I mentioned earlier as well. And the ocean, like ocean acidification, because that is one of the different constituents which is in the ocean water, which can vary depending upon the temperature. So that is one of the climate indicator. Then you all know that sea level, because if the sea level is if increases to about zero point 0.5 to 1 centimeter, many small islands can submerge in the ocean. So, various reasons it can change. We will also come to see a couple of things in the later discussion or slides. And another important aspects of the cryosphere, as I mentioned, it is covered with either snow or the glacier. So the glacier is depending upon the glacier mass balance, because if there is if you know that over Himalaya, the glaciers start melting depending upon your season. During the summer and spring, you get minimum glacier coverage, whereas in winter it will be accumulated back because of the temperature drop in the seasonal cycle. It will be accumulated. So glacier mass balance is an important climate indicator. Okay, because you might have read several articles saying that the glacier melt is happening in various places across the globe, like Alps as well as over the Himalaya. And same way, you know that our both the poles, the Arctic and Antarctic, is with a lot of sea ice cover. Okay, so in the Arctic Ocean, you can have a large amount of the ocean is covered with a very thick sea ice, but due to the temperature warming, the sea ice can melt. So what will happen? The melting sea ice can contribute to rise in sea level. Okay, that is just a conservation of mass principle. So these are the major climate indicators I just want to introduce. Then, as I mentioned in the very beginning, that the most of this Earth, the atmosphere, the control of the Earth's climate system, which include all the five spheres, is controlled by only single prime source, that is the solar radiation, which is coming from sun. That is the primary and only source. And then there will be a radiative energy balance should be existing. It is nothing but how much our incoming sunlight, which is falling on the climate system, should balance with whatever is emitting back. So only thing is the emitting the coming rays in a different wavelength, while it is emitting in a different wavelength. It is based on a very simple physics law. That is, you can also see here. I put this F is equal to sigma T for the Stefan Boltzmann constant, and F is the flux, radiative flux. It depends upon the temperature. So as I mentioned, since solar energy coming from the sun is at very high temperature, so the emitting wavelength is much lower. So you know that the maximum the wavelength is about zero point 0.5 micron, whereas the Earth temperature is much smaller. The average temperature is about 15 degrees centigrade. What I'm saying is a global average temperature, not at our one particular place. So in that, if that is the average temperature, what the maximum wavelength and energy will be is about 10 micron. Okay. So why I'm showing this? I wanted to show the Earth radiation balance. Whatever the solar radiation which is coming in is at very high wavelength, whereas whatever is very short wavelength, that is about 0.5 micron, whereas which is going out is at a lower temperature but with a higher wavelength. And then what there is one more another important feature, that the constituents in our atmosphere can absorb this emitting radiation. That is, whatever the radiation coming from sun is called the shortwave radiation because it is in the shortwave range. Whatever going back is called long wave radiation because it is in the long wave wavelength. So in this long wave radiation can be trapped by many of the constituents. So this graph, what I am trying to show you is for different wavelengths, what is the kind of an absorption spectra. This is also a very fundamental figure, but I just wanted to bring out here that as I mentioned, when the solar radiation, which is emitting from the earth, it is at the wavelength of about, average wavelength is about 10 micron or higher, then you see the here, the moment I say if it is 100% means the complete radiation is trapped. So anything above 13 micron is absorbed by either water vapor or by CO2. So this is very important. The water vapor is always exists in our atmosphere because the water vapor exists in the atmosphere in the form of gas. Okay, whereas CO2 is seems to be not that much of variant, whereas water vapor is very much variant. Why? Because you know that the cloud system, which can hold water in various places in various amount. That is why you get rain at some location, rain at not at some location, because that is due to the availability of moisture at that location. But you know that entire earth is covered with a lot of moisture, so that is one of the greenhouse gas. So here comes the question. So we have abundant amount of water vapor, but only very minimal amount of CO2. For example, if you take a 100 unit volume of air, then you will see that the maximum the constituent of element exists in that column is nitrogen. That is about 78%. Then comes other elements. So compared to CO2, H2O is very big, but CO2 is only parts per million. That is about very minute. Then why we need to worry about climate change and CO2? Because you are always listening about CO2 and this much of little amount of CO2, how it can harm this much to our climate system. The answer is you all might have heard and you may be taught even teaching in every your class lectures also about the half-life time period, because the CO2 half-life time period is about 100 years, whereas the water vapor, the half-life time is may not be that. It is maybe few hours to a few days only. So whatever changes which is coming to CO2, which will last for next 100 years. That is why it is so important, and also the important in the scientifically, because CO2 absorb all its emitting radiation almost 100% or above 90%. So this is the important factor I wanted to introduce. Next comes to the balance between solar radiation and thermal radiation. That is the basis for all this phenomena. So, for example, this is the simple radiation budget calculation. For example, as you if you know the solar constant, and if you see that only 341 watt per meter square is the quantity of energy which is coming from the sun, then what will happen? There is some fraction which can be reflected due to the clouds or whatever present in the atmosphere or the envelope of the earth. The remaining part can come, but then again something from the surface, either ocean surface or over the land, which can also reflect. Okay, that is what is called albedo. So that is also reflect about some amount, and only the remaining, for example, 341, if it comes, only 161 is finally getting into our earth. So that is what is there. As per the earth radiation balance, whatever coming in, it should go back. So we should have a emitting radiation. It should come here. But emitting is bit complicated, as I said, because there is a large absorption bands for different constituents. So the coming solar radiation is very clean. Only you will have reflection and some reflection on the surface, some at the atmosphere, but remaining coming in. Whereas in the emitting radiation, only very few packets will be going out without doing anything. That is through the absorption window also. You could see that certain wavelength will not get absorbed, it will go out. So that is only 40 units. If you take about 396 unit, which is emitting, then only 356 is coming and interacting with atmosphere. Then atmosphere, what it can do, it can, depending upon the amount of other constituents, it can tap all this and re-emit it. So then finally what will happen, it will be emitting and you will get about 239. This will be simple radiation balance calculation. Shortwave, if it is coming 341, two is combinedly reflecting back, 239 is something remaining, that 239 is going back. So there is a perfect radiation balance. Then what is the problem? If that is the radiation balance exists, we will have a constant or at least over a climate sense for 30 years, we will have a constant temperature. So I will also give you a small mathematical calculation to find out what is the mean temperature if such a radiation balance is existing. So that is what I wanted to show here with a this is simple calculation of radiative equilibrium temperature. So as you know that our Earth, you just assume the Earth as a sphere. Then if solar radiation is coming from thousands of kilometers away, so the radiation falls on the surface in a circular fashion. That is why the area is represented in pi r square. And you know the flux, which is sigma t raised to 4, and there is an absorption coefficient also you can think, but you can put 1 because we assume that there is no absorption or no atmosphere. Then you can put it as 1. So that should be balanced with whatever is going back. Okay. So this is our incoming solar radiation. This is what is going out. In the going out, what we will get, we will assume if there is no atmosphere, this is 1. And what is this alpha? This is what I said. Some of the solar radiation, about 30% will be reflecting back. So you put a rough value of about 30%. Then if you compute, you will get the mean temperature of the atmosphere is about minus 18 degrees centigrade. But we all know that it is not correct because the mean temperature of the atmosphere is about 15 degrees. That means altogether there is a 33 Kelvin should be warming, the 33 Kelvin temperature should we need excess. Where that comes, here I put a condition, tau equal to 1 means I eliminated the atmosphere. So the atmosphere contribute about this 33 degree Kelvin. So who is this atmosphere? That is those elements which is called greenhouse gases because they are the one trapping this long wave radiation. So why I am showing all these description before and computation here to understand you that greenhouse gas is not a enemy. It is a requirement for maintaining our global temperature at 15 degrees. But when it will become harmful, when it become in abundance, that is the atmosphere, those constituents, when it become whatever we are having in this to maintain 15 degree, instead of that, if you get this tau value much larger, we will get much warmer temperature. Okay, so that is why the greenhouse gas is equally important, but at the same time, the amount should not exceed as well. So the only one important takeaway from here is greenhouse gas is an essential to maintain our Earth's temperature. Otherwise, we will become other planets like which doesn't have any atmosphere. Then the temperature will go to minus 15 or minus 25, minus 60 kind of a temperature. But this atmosphere and its envelope and this globe, the constituents like CO2, methane, nitrous oxide, ozone, water vapor, sulfur dioxide, all these elements are trapping this outgoing radiation and keeping our Earth warmer. But when the amount of that, these elements, when it is exceeding, we are experiencing this global warming. So this is the simple basis which I am trying to explain. Okay, as I mentioned, There are how this CO2 can or other constituents, or the greenhouse gas constituents can vary, which can vary either through natural effect or through man-made effect. What are all the natural effects? Natural, as this is the two part I mentioned, that natural and anthropogenic. That is, anthropogenic is nothing but man-made changes. So let us first see the natural possibilities. The natural possibilities, one is we know that the change in the sun's energy, because you all studied and you are all aware about the solar flares, because the solar energy. Uh, Hello, am I audible?
Yes, sir. You are audible.
Yeah, yeah.
Yes.
Okay, okay. So this solar energy, during the solar flare time, it will get amplified, and sometime it can reduce. So this is the kind of a small variations will happen over several years time. So we are also talking about climate. So this is also kind of a longer time scale. So it can impact our the changes in the climate system. So another possibility is like variation in the Earth orbit. We know that Earth orbit will go slightly plus minus. So that can also contribute to the amount of solar radiation which is falling on our Earth's surface, uh, depending upon the orbital parameter. Again, that is over a time scale of about thousands of years. And another slightly shorter time scale is what is called volcanic eruption, because there are several volcanic eruption. For example, one big one in Manitoba eruption, which has happened in around 60s and 70s. If you see the temperature, what will happen? This lot of dust and this greenhouse gases which is emitting from the volcanic eruption will be directly pumping into stratosphere. If it is in the lower layer of the atmosphere, what will happen? We will have a lot of the wind and circulation, which will take away, and make it uniformly distributed, and it will get diluted. Whereas it is pumping into stratosphere, it can stay there for long time, which can immediately affect our climate. That is why whenever a major volcanic eruption happens, our Earth temperature will go down. So that very clear evidences has been there in the observation as well. So another, as I mentioned about the second aspect, is the anthropogenic causes of climate change. So here is what our role, because all these changes is done by nobody else, only us. So in the form of burning of fossil fuels, either through factory, running car, or burning coals. Okay, and another important aspect is the deforestation, which will change our land cover. As you know that the land cover is the major example is Amazonian forest. It has been very much reduced drastically, and it will have a lot of climatic impact. Okay, another one is the agriculture and the waste, because that is also, as we know, that our population is going higher and high, and especially in India now, we are the most populated country among the world other countries. So we are going to face this problem much in a severe way. The waste which we generated, we are not able to dispose it properly, and some are not degradable. So these are all also adding to the ooze too much. Okay. So as I mentioned before that there is a natural variability. For
Sir,
example, there was a the indication, and also many people studied before, saying that this is actually about what I am showing in this graph. It is something like you can see that 800 or 800,000 years before. How we get this 8,000, 100,000 years before temperature? We will go to the polar region where it is less disturbed and do the drilling. We will drill about a few, maybe about 3 to 4 kilometers down, and get the samples. That is called cores. When we take that cores, there inside the core there will be the air bubbles which will be trapped. That will depend through dating. Either then we will be able to find out the time when it has been formed and when it has been trapped. But what is happening in the trapped air bubble, which will represent the air at that time, that will be about 800 years. So through this ice core measurements, we can reconstruct the temperature. So that is what that it shows that there are there are epochs where we get temperature much lower. There are epochs we get temperature at higher values. But you please note that this temperature range of variation is only maximum of 10 degrees or 12 degrees. But you have to now come to see the temperature which is varying in the last 20 or 50 years is much, much higher than this. That is why we are all worried about the climate change, and it is so important aspect, and it became very much we are needful to control the temperature with whatever way we wanted to do. That is why we were even discussing that in the later part about the carbon neutrality. Okay. So the second figure which I am showing here is a two factor. That is, you all might have been heard some 10, 20 years before people used to say that our climate is varying according to the variations of the solar radiance. That is due to the solar flares. It is called solar cycle, which we generally people used to study and say that there are 11-year cycle is existing. But in the if you see the red curve, that is nothing but our temperature. So in those last 1 century or 2 century, we could see that the natural variability of the climate of this temperature, our Earth system, was also more or less similar with the 11-year cycle. So we could easily relate that there is a relationship with our climate change and the solar cycle. But actual climate change has happened only in the last 35 to 40 years, where we are releasing abundant amount of greenhouse gases into the atmosphere due to our own various revolutions, like either green revolution or industrial revolution, whatever it is. But during that, what is happening is you can see the temperature rise is very steep and drastically increasing, but the solar cycle is still in its natural variability. What is now people came to the conclusion, seeing this figure at the last 25 years, that there is no relationship between 11-year solar cycle and climate change, because that is solar variation, the solar flare variation. It is a natural variability of the solar system. Okay, so now let us see. I mentioned about the natural causes as well as the man-made causes. So how we will delineate these two and study based using some data. So what is the one method is the modeling, which I will come little later. How we model that part I will also explain to you. And this is the context you all heard about the IPCC. IPCC is the Inter-Panel Panel for Climate Change Studies, and they have come up with a concise report with several versions, IPCC 1, 2, 3, like now we are into IPCC 7. So in each version, what we are going to do, we are adding new and new information and new studies and newer understanding. So in that, they have done a series of experiments. These are model studies based on the observation and forcing of the model. So only you consider natural variation of the greenhouse gases. Other gases like man-made changes, you keep constant. Then you see this green line. Okay, so if you see, this is the black line is our actual observation temperature. This is what we have plotted in the y-axis anomaly. Anomaly is nothing but you take a base period of about 30 years. That is what is representing climate. In this case, maybe 1950 to 1980 period. That will be 30 years, and then you subtract every year temperature, and you get the value. So you will get there is not much change in this up to here, but recent 25 to 30 years, there is a drastic increase in temperature. That is what is representing our climate change. But in the if the natural causes is not really causing to this present change, because you can see in the last 40 or 50 years, other than one strong volcanic eruption here, which showed this cooling here. Other than that, there was no much major volcanic eruption or any kind of a natural variability. That is why it is in all this contribution of increasing is coming from the man-made contribution. Only thing now changes is due to the aerosol. Aerosol is also due to human contribution, because the vehicular pollution, like you all heard about PM 2.5, that is kind of a particle which will be ejected into our atmosphere. So there is a two-fold effect of this aerosol. So one part is it can amplify the effect, there will be a dimming effect. So depending upon the radiation, how it will interact with which constituent. Aerosols also can be black carbon, sea salt, organic carbon. So different varieties. Each species will interact different way with the solar radiation, and contributions will be different way. But if you eliminate this and if you take the combined effect, you still feel it is much more matching with what is observation. So the main contribution coming from greenhouse gas, which humans are responsible. That is the point we wanted to tell here. So as I showed, one of the implication of this increasing CO2 or the greenhouse gases into atmosphere is nothing but the increase in temperature, because there is a one-to-one correspondence with the CO2 increase and temperature increase, especially in the last 50 years. If you see, there is a very drastic increase in the temperature. So that is what. Then every year we are reading in paper that last year was the hottest year in the world, and especially this year we is saying that if you take last 10 year, people will say out of 10 year, 5 year will be considered as most record breaking warmest year, something like that. So even 2024 is recorded about 1.6 degrees centigrade above the global average temperature during this base period. So it shows that this is the record warmest year, 2024. And 25 also is going to be either equal or slightly above, because you already started reading the temperature reports from Spain and European countries that it is very high temperature which they never experienced in their life before. And even the France is now looking for a alternate housing arrangement, because in none of their houses were having air cooler. But now they wanted to think about it, because in the history their temperature never reached up to this, so they didn't want to use anything and there was no requirement. But now they started thinking how they can change their housing system, cooling system, everything. So which shows that our temperature in the air climate system is changing drastically and anomalously high. So every year, see here, what I'm showing here is your left side is the temperature, surface temperature anomaly in 2024, and on the right side is extreme values. For example, the temperature over a day, it may be about 2.5 degree, or maybe, but if you take in some particular event, okay, so from some 2 days or 3 days, it will be something like a hot event. That time it can shoot up to 5 degrees, but it will be for a very short time. Okay, so that if you pick that, you will see that most of the region, you can see the red color. That means which is showing in red color is warmest, because there unprecedentedly warm temperature you can experience. This is across the globe. This is from the global data which is available from NASA and European Center. Okay, so now let us, this is the one interesting figure I thought I would like to show you. This is the global warming in terms of temperature for 2024, last year, only for last year, how the climate of last year was changing from the previous 30 year with respect to 2024 for each country. Okay, so here what I am putting it in the blue circle is for India. So India, it is only plus 1.1 degree centigrade. This is, I am not saying any particular location like Trivandrum, Cochin, or Bangalore. It is for entire India. Okay, So if you take entire India, average temperature or 2024 is plus 1 degree centigrade. But you see, there are some countries, especially the European countries. Okay, there you get even the check. See, for example, you take somewhere uh, uh, Belarus. Belarus experienced about 3.4 degrees centigrade. Again, there is, if you see in some round, I put a red, a black circle, outline circle. What it shows is 2024 was the record highest value they got in those countries. If you see that many countries got that envelope, that means many countries started experiencing record temperature in the last year. If you see 1 year after, maybe this year, the picture will not be different. I feel the red color will be more. Okay. And another one is this is about the sea ice extent. As I mentioned, we have both poles, which will be covered with ice. And due to the temperature rise, this ice is started melting. This ice is started melting. So this melting ice is causing a sea level rise. That will be one of the issue. Another thing is nowadays, I don't know how many of you may be traveling to either Europe or to US from India. You can see if 10 years before, if you are flying, your flights will not go to the northern pole, but now most of the airlines are preferring that route. Why? Because the temperature on that part is much smaller, it's much warmer. So the aircraft need less energy to maintain, and then shorter route they will get. So it's a financing. The aircraft can be reach the location at faster time with less fuel. It will be more economical. So they are making money out of it. So that is the industry making money, but it is further adding to the global warming, because each aircraft will releasing a large amount of the greenhouse gas, which will be adding to or amplifying the climate change. Okay, so now let us come to the sea level rise. As I mentioned at the beginning, that sea level rise is one of the major cause for submerging many of the islands, which is either with the sea level. For example, we also have island in Lakshadweep, and Mauritius Islands are there, adjacent to our country. So all these are the very much line with the present sea level. So if there is a even 1 millimeter or 1 centimeter rise, can cause lot of small islands can submerge. So this is what is the present condition. You can see that about 0.43 centimeter per year is kind of a rate at which the sea level is rising, partly contributed from the glacier melt as well as the pH melt. Okay, so now another important aspect. You all know that in 2024, last year, we got Wayanad landslide. Before landslide, we got lot of rain and we got an extreme rain event. Just due to the extreme rain event, we got this landslide. Even this year, we got the similar landslide, or maybe at a very small scale at Munnar, but there was not much casualty, luckily. But these extreme events are extremely dangerous. So here, if you see the IPCC and the World Meteorological Organization together came up with some kind of a categorizing. What are all the reasons, or what are all the extremes are more frequent or more happening due to climate change? So they found that the most the occurrence is heat wave. That is what is even this year Europe is facing now. And then comes flood, then comes drought. So it is not always flood. Some places when it is flooded, some places will be observing severe drought. Then there is a wind gust. You also are noticing that the cyclones which are forming 10 years before and now, the intensity is very high. So the damage, the wind due to the cyclone is very, very severe. So though we have a lot of preparatory measures, the damage is still increasing. And same way, hail, which is not a problem for us, but at northern part of India, as well as in the other mid-latitude regions will be getting severe hail. And but in India, recent years, if you see the casualty which is happening due to lightning, the lightning casualty, especially in the southern part, maybe not that high, but over the middle part of India as well as the northern part of India, most of the casualties are now coming due to lightning. So in this is actually a global average, but our India context may be slightly different. We need to see. So there are so many other factors. So that is what. So this is another interesting figure which I thought I will show you. It may be interesting because the people who are all born like 1950s, maybe our parents, and they may be experiencing this warm or the global warming towards their at the end of maybe about 70 years or around 60 years old. But people who are in my age, or maybe my students' age, may be experiencing in their adult self. But you just imagine the kids which are born now are just born with the climate change. So we don't know how they will be experiencing what kind of a climate when they reach at the age of 70. So it is very alarming. So that is what I wanted to initially introduce about the climate change. You know the climate change and the severity. This is what I tried to bring out to you. And now I thought I will touch upon Kerala. Since initially I thought this FDP program, maybe many of you are from Kerala, but now I came to know you are all from different parts of the country. But please bear with me. I will be showing a little bit more details on Kerala related aspects. So in Kerala, as you know, here I have put on the geographical map in which you can see Kerala is very peculiar because it is like a north-south oriented. Kerala has long coast, very short midland. Then we do have a very highland. So all this apart within 25 to 30 kilometers, all these things will be experienced. So Kerala terrain is too complex. So we get, so as I mentioned, the climate change is a global problem. Okay, but the impact of climate change is very, very local. So, for example, as I mentioned in my previous slide, I showed that the extreme events, either in terms of flood or drought or landslide, which will be happening in a local scale. For example, it happened in Wayanad, that will be over a particular area. So, same way, the impact will be local. So, especially for this highly varying terrain, the impact will be manifold larger than over a uniform terrain or regions like other part. But we have issues due to various factors. For example, we do have flash flood, we have drought. Flash flood we have already experienced in 2018. We do have a drought. Even in 2023, we got drought over Bharatapura region and sea level rise. Of course, we are facing problem in the part of middle Kerala due to the sea level rise and the tide variations. Many places like in Cochin getting inundated, and we get a lot of cyclone, which was earlier rare in Arabian Sea because the Arabian Sea side of the ocean was less in temperature. But nowadays, Arabian Sea is getting warming up, so many cyclones started forming in Arabian Sea. Earlier, we used to get cyclone only over the Bay of Bengal, and Tamil Nadu was much affected. But now it is Kerala also equally affected. Not only that, earlier cyclones which were coming in Arabian Sea will not go north further. But nowadays, any cyclone which is forming in Arabian Sea, which even go up to Oman and getting rain in the Middle East. So giving a lot of trouble to them. And another aspect, as I mentioned, landslide. Then we have coastal erosion issues, soil pulping. That is what is ultimately leading to landslide. Okay, this is some of the clips which I wanted to show. What I mentioned is in Bharatapura Basin, and this is according to the 2018 flood, which many of you might have read it in paper as well as experienced. And same year in August, like in August 23, okay, the same area, Bharatapura, got very severe drought, which very much affected for the agriculture part. The same way, this Pamba Basin, okay, so the Pampa Basin is also affected by rain in 2018. In 2023, we got large severe scarcity of water there. People were struggling for water. So we get both extremes, either flood or drought. And same way in Trivandrum, Cochin, that is urban flooding. We have severe water stress issues. So all this is coming in different sector, like in agriculture as well as in the fisheries sector. Another important aspect, as I mentioned, that we have a island called Lakshadweep, and which many of you might have been already visited. It's very beautiful place. You might have seen the area is completely built up on a coral. Because of the coral, we get coral is protecting the ocean waves, which will not be coming and seeping into the land area, because coral will act as a wave breaker. But if with the high temperature, especially the ocean temperature is increasing, due to high temperature, there is a feature called the coral bleaching. So when coral bleaching is nothing but the coral will die off. Once the coral is dying off, it will loosen from that ground. Then it cannot protect the wave. So the waves which are now protected by the coral will come into the land, and that will be more devastating. The same way, the the acidification part, because we do put a lot of waste into our rivers, and that is what is now you may see in 24 in Ashtamudi Lake. That is one of the lake in Kerala. We found huge volume of fish were dying and coming out of the lake. And this is what I was saying about the sea level change, which is causing large amount of waves, which is coming even inland of like in Cochin area. Okay. Then another important area aspect is the livestock. So the decreased livestock productivity, animal health risk, spread of infectious diseases, reduced fodder availability, all this is the impact of climate change, especially for the livestock. So I'm just saying this is Kerala. Doesn't mean that it's only for Kerala. It is applicable to many states. So I just maybe for other states many more aspects, but I'm also about the forest area. See, this is another aspect in Munnar landslide. Even this year there was a landslide that is basically due to the road cutting, various factors, and uh, and also due to extreme rain. But due to during drought, especially during the 2019, Munnar didn't get much rain, and it was very high temperature during time. Became a forest fire. Usually, forest fire is not that frequent or not much known to these places, but it is happening in Vatavada. That is one of the Munnar forest, which has this fire has been happened. So that it means there is a changes, or the climate is affecting to the various sectors. And same way biodiversity. There are several rare species which are all disappearing, like birds or even the deer, which is all affected by, that means the biodiversity is very much affected by climate change. And this is one of the another example with the energy sector. This has happened in Trivandrum during 2023, during a very heavy extreme rainfall event, which bring down the whole grid, electric grid, and there was no power because of this kind of a effect. So the extreme events and the extreme events can cause various sectors, even in tourism sectors, and the beaches which has been washed away, and the roads will be taken away, all those things. So same way, the urban life and transportation network. That also, this is one of the Bangalore Sustainability Forum developed this figure. So I borrowed from them. There also you can make a lot of issues due to heat wave, flash flood, interrupted water supply, spread of disease. Because even Bangalore is actually about 900 meters above sea level, but extreme rain a couple of years back made Bangalore flooded. So that kind of a unseasonal, un in kind of a extreme events can cause a lot of damages. So there is a lot of economical losses it can create. So this is in general, I have covered everything. So let me come to the changes in temperature. This is the temperature signal, which we can see. that all over the globe temperature is increasing. Same kind of trend is available in Kerala. But there is an important aspect I wanted to bring to your attention. That is what in Kerala, that is over the Kerala, basically the Western Ghat part is more because we have a very highland region and also I mentioned a small midland and then coastal area. But it is all these places that the seasonal rainfall, the total amount, we get extreme events very frequently, but there are days which you don't have much rain, and the total amount of rainfall which is expected to get over period like for during summer monsoon or even northeast monsoon, that is the June to September or October to December period is reducing it. So that is the one of the aspects which we need to see. But there are some trend analysis and all those things. So this is the one of the interesting report from my center. Every year, our chief minister releases. This is the climate statement of Kerala. This is released by Honorable Chief Minister during Science Congress every year, starting from last 2021. Now this is the fourth year, has been last February. It has been released. So it will have a quite summary observations based information is available. If any of you interested, please go to our website iccs.res.in. It will be provided there. Not only this year, previous reports also you can see. And you can also see how this extreme events frequency is increasing, how temperature is increasing. So as I mentioned, all this is observation. So what we wanted to know, if this is a kind of a scenario, so means that the CO2 is or the methane or even other greenhouse gases is increasing at certain rate. But we don't know what will happen tomorrow. How we will know? Only by using numerical models. So that is why we use computer models for predicting or simulating these climate situations in 10 years from now, 20 years from now, end of the century like simulations. So we use various the models which will have the all Earth system, which has atmosphere, ocean, sea ice, then it will have biosphere, even biogeochemistry of the ocean. So it is a highly complex model which requires supercomputer to run. So we do have our Bangalore center. We have a 4 petaflop computing machine, and also I have worked with other centers who all having supercomputer. Even in Kottayam center, we are now in the process of acquiring a small supercomputer, which is going on. Okay, so let us come to the what is the physical principle which we'll be using in these models. It is nothing but basic equations for conservation of momentum. First equation is for conservation of momentum. It is in the vector form, and also you can see that it can have in x, y, z direction. So you can think about latitude, longitude, and vertical. And then we do have a thermodynamic, that is the energy balance equation. There's mass continuity equation. Then we can have a hydrostatic balance because you are working on a on from surface to top of the atmosphere. Then we, as I mentioned, we have in the earth envelope there is a abundant amount of water vapor. So we should have a water vapor mass continuity. So what is this? On the left hand side is basically the time changes as well as the advection times. On the right hand side, you see some the terms like F, Q, S. This is the forcing times. So that is the uncertainty because you say if I have a model which is perfect, I can tell tomorrow 100% is accurate. But why we cannot say? Because we are making assumptions in these terms. This is what is our knowledge about the atmospheric or oceanic or cryospheric system. What is the forcing it will be giving it there? That is what is varying from person to person to whom they develop according to their knowledge or the knowledge which we acquired. So that makes the accuracy of your model. Okay, so for example, I wanted to tell you that one of the term like F or Q, which will depend upon various processes. For example, in the atmosphere, what will happen? We have mountain, we have waves, the wind will be flowing over mountain that will generate some gravity wave. Then we have a turbulent diffusion. and we have sensible latent flux coming from the ocean. We need to take into account. Then we do have very big cloud, small cloud, and we do have a little bit larger spreading cloud. So all these different types of clouds, which will have different kind of a rainfall, all these processes we need to take into account. And basically, we also need to conserve the radiation balance. So all these things will give you that equations, and that equation will be solved in in every grid, because we make the globe into several small grid that will represent your area. So if you go smaller and smaller, the number of calculations will be multiplied by 3, 4, 5 times, because you have ocean below several layers, atmosphere above, mountain this many layers. So you just imagine one variable, how many layers, and one grid, how many different parameters. Accordingly, your dimensions will be multiplied by either in space or in time or in variable or in levels. Okay, so it is highly complex system, but these models are we were using for making the position. If you use such model, if you make the simulation of the temperature or rainfall, this is the very immediate variable I can show you, but we have around 128 variables for different parameters. Out of that, the most commonly known and used and experienced parameters, temperature and rainfall. So you can see that temperature that shows a very systematic increase from historic means it is present day. After 20 years, this will be increasing this much. After another 40 years, this will be end of the century, we will get such a huge change. The same way, the rainfall also. But rainfall is little bit tricky because in the rainfall will vary, as you also know, like if you get rainfall in Trivandrum, you may not get rainfall in Bangalore. So there is a large spatial variability. So models will have less accurate in predicting this model, the variable. So the projections will also will have its own issue. So that is why this IPCC model says that over India rainfall is increasing. But in our own work with the Japan government, and we have developed a very high resolution model. In you can see all our references are here, and also come to our website. It will be all downloadable. If somebody is interested, they can download and read the paper. What we have found was if you use very high resolution, that means about 20 kilometer spatial resolution across the globe. If you use such a model, you will see that if you simulate the model to 100 years, end of the 100 year, if you see how the temperature and rainfall, temperature, there is no issue, it will be increasing. But rainfall, you see the western blue region over the west coast, that is including Kerala, part of Mangalore, or Karnataka, or over the Maharashtra, these region get a reduction of rainfall. So this you can get only if your model is sufficiently large enough to resolve major orographic as well as the minute features of the physical features of the particular region. Then only you will be able to get the detailed forecast with realistic variation. Why I'm saying realistic? Because on the left-hand side, the observed trend in the past 50 years also shows this is what is now even this year or last year observation also shows that. But only problem why then it is not most of the other people are using this required the world fastest computer to run. So this is done in an Earth simulator. That was one of the fastest computer in the world, which was located in Tokyo. This because of that we could run that. This is not possible everywhere to run. Then what is the another aspect is what we can do. We can also do. You take such a good model output and then force a regional model, which you might have been also heard about the weather forecast model, which people uses for weather forecast over a small region, WRF. So we have done converted a regional model that is called RCM, which required input from the global model and do the simulation and see how this at 1 kilometer resolution, how the variation that also shows there is a drastic decrease in the rainfall over the west coast region. So now, can I have another how much more time?
Sir, up to 7:30.
30. Okay, fine. So I will be able to finish by that. Okay, so now I have already talked about the basis of climate change, the theory behind it, how we can explain about the maintenance of the temperature over the earth to our mean climate and why it is varying it, what is the importance of the climate change aspects and how in which sector it is affecting, not only for Kerala, other parts of the regions as well, and what are all the consequences of this. So now this brings to the importance of carbon neutrality. So what I said is that climate change, it is real, it is happening, it is shown in different sectors, and it's evidence which I have been described. Now we know that how we can control this, or how we can at least manage it. That is why people talk about the climate resilience and climate the climate mitigation, and then comes last the adaptation. What it is, the mitigation is how you can avoid or how you can control. If you cannot control, then you have to live with it. That is the stage, the adaptation. So I will now describe the carbon neutrality, which is nothing but achieving a balance between the carbon emitted and the carbon absorbed from the atmosphere. So we should have a balance. That is what is called net zero carbon footprint, people used to call. So idea is nothing but you first reduce the emission of carbon, which is emitting to the atmosphere. Then what about you can how you will reduce, either by controlling or by alternate sources you use, and even if that still reminiscence will be there, that you can offset using some other method. Okay. So then there are two more terms you need to be you are all or maybe familiar. That is carbon negative and carbon positive. Carbon negative is nothing but see, you have a basic state of carbon dioxide in the atmosphere. If you removing that, and if it is removing more, then it will be negative. And if you are adding that, then it will be positive. It's a simple logic. So let us come to know who are all the major emitters in the world. Okay, this is based on 2023 statistics. Even 2024 or 25 is not much change. As you know, the most developed countries are emitting more, and or maybe the developing countries are also emitting more. So the first is always the China. Second is United States. We comes under third position. So these are the why this much of an emission, because these are the countries they primarily use the source for energy for their requirement is met from either the the greenhouse gas emitting method. For example, one is coal for producing energy. Using generating energy, they burn coal. Then it will emit that much of amount of CO2. So the power industry is the largest emitter. Even this year, it is the largest. So that means we were saying that coal usage has to be reduced, it has been removed, alternate sources has to be found out. We should go for renewable energy. All those things are there, and the effort is going on. It is we are slowly replacing it. But even today, the major energy requirement is met by burning fossil fuel only. Okay, so that is why the major these countries are contributing to this the CO2 to the atmosphere or the other greenhouse gases to the atmosphere. So this is what different sectors. Okay, okay. So this figure shows how we meet the energy requirement, or maybe by burning CO2 and emitting CO2 uh, from different sectors. So here what you see, the yellow color correspond to coal. So the coal burning is the major source even now. Now the second comes the gas. That is the light blue, and the dark color is the oil burning. So these are the three major thing even today. So that is why the alternate source of energy is very crucial to control this greenhouse gas emission. So I wanted to bring out a very important statistics through this slide. So this is what it is showing is this is the World Economic Forum. Every year they come up with what is the long-term risk outlook. For example, in the next 10 years, which is the maximum financial loss making risk which is going to happen or which is contributing. So you see here many dots are with the green color. So the green color dots are, for example, extreme weather is basically environmental issue. Another one is climate action failure, because many countries agree that they will follow the carbon neutral or the net zero emission by this year, but later they withdraw or later they change their plan. So that is also an environmental issue it will cause. Then the natural disasters like the forest fire, all those things also will be contributing. It is also an environmental issue. Biodiversity loss, human-made environmental disasters. So all these major economic loss or the risk in the next 10 years is due to the environmental issue. That is the highlight. So all the other things are after these five major things. So in this year also they have came up with that. Maybe the major first four is still environmental issues. Maybe instead of five now it became four because due to this the disturbances which is happening across the world between different countries, there is a lot of human displacement. So that became one of the risks now. Because of that, one of the environment list one item has been moved from fifth place to 10th place. But still, I can say out of the 10, at least five are due to environmental issues. That is because that is shows that the carbon neutrality or the net zero commitment is an important aspect that one needs to be really worried about. So that what is net zero commitment? You might have all heard about the Paris commitment, in which the 190 countries agreed that they will curtail the global warming to 1.5 degrees centigrade by becoming net zero by 20. Yeah, am I not audible? Is it okay? Somebody
Yes,
was
sir,
saying
you're
that.
audible.
Okay, okay, fine. So 1.5 degrees centigrade above the pre-industrial level. Currently, Earth is already, as you know, that if you want to control the Earth mean climate variation by 1.5 degrees centigrade, you need to have carbon neutral or net zero commitment should by 2050. So that is what this is showing, that you can read it. Emission need to be reduced. The present emission needs to be reduced by about half, about 45% by 2030. Then we can reach a net zero by 2050. Another 20 years, we will be able to come to the emission will be equal to what is getting absorbed. Okay, so that state we can give in a pictorial form. We can say this way. See, for example, we are now here if you wanted to bring by 2050, if you want to get net zero, by 2030, you should reduce about 35 to about 45% of the present emission by alternate sources, either by mitigating to the other technique like using solar, wind, or whatever form you need to use. And then comes the carbon removal. Whatever is remaining, then you can achieve this target much before. For example, if you say that if you will reduce the carbon emission by 2030 about 50% of now, if you could remove or reduce maybe around 60%, your target you will achieve much earlier. Okay, so the another one important fact that the carbon footprint. Okay, this is something like carbon CO2 emission in grams per person per kilogram. Okay, for example, if you travel in a bus or in a mass communication where hundreds of people travel together, when we are responsible for emitting less than 1 gram per person. But if you getting into some kind of a bus instead of train, it will increase to 30 times. Then if you use car, nowadays everybody has car. So you have each person is responsible for 160 gram emission. And you may be knowing that the enormous amount of increase in the airline industry now, because the millions of people travel now, that goes about 238 gram per person emission. So this shows that there is a very coordinated and very large scale control mechanism each country has to put in to control this. And as you see, the most carbon emission per capita by country, and leading by US because they are a rich country. The second will be China, but in number wise, which larger. So in total volume, this will be either China will be first and US is second, and then comes India. Okay. So as I mentioned about IPCC and UN, they have a roadmap. As I mentioned before, if you want to keep the temperature warming below 1.5 degree, but if you see last year temperature, global temperature has been already crossed 1.5. Okay, so but when a couple of years back when they planned, they thought that 1.5 degree will be reached only in 2050. But by the time if you reduce your emission in 2030 by 50%, we will be able to achieve. But now looks like it's a very difficult target and it looks like an unattainable target. But at least the efforts are going on. Every country is trying. Many countries are committed. Even India extended our period instead of 250 to 270. So I will be coming to that. For example, okay, this is the figure which shows individual countries who are all what is their target. For example, European Union and UK, Japan, their net zero target is by 2050. That means by 2030, they will find alternate sources for the release of CO2 of present position to 50% by 2030. And whereas China is aiming at 2060, India in 2070. Okay. And India's commitment to climate action, there are several which you are also familiar. As I mentioned, India is aiming for net zero by 2070, which is announced in our 26th session of the United States Framework Convention on Climate Change in 2021. These are all the major initiatives which India are doing, like Ek Pet, this is like a one tree program, planting one tree. In Kerala also, in a different state, they will call it in different local name, but this program is all over India, is going on, and there are a lot of positive impact as well. And there is a green credit program. That is also another important thing because, for example, if you compute the net your contribution to the net zero program, and if you add more, then it is something like you can credit that much into an account, and then later you can credit back. This is a kind of a credit system, and this is how effective it is and how much it is going and popularizing. We need to see, but as and when time goes, it is increasing that. And the National Afforestation Program is one of the India's major program, and compensatory afforestation under CAMPA, and the National Clean Air Program. There are several others are also in pipeline. Even now, yesterday, I was also attending the National Adaptation Program, in which also they are planning a lot of mitigating, strengthening the mitigation, as well as they are going one step ahead for planning the adaptation. So our Prime Minister already made 5 pledges, which is all I listed here. India will increase its non-fossil energy capacity to 500 gigawatt by 2030. That will be actually, we aimed for 2070 by reducing the emission by 45%. But with this promise, we may be already ahead. Like that means we can achieve, instead of 2070, we can achieve much earlier, because that the conversion of energy from non-fossil to renewable in going in very fast rate, at least in several states. Okay, especially in Gujarat and Maharashtra, Karnataka, many states, Tamil Nadu, all are going at a very faster rate. India will meet about 50% of energy requirement from renewable, which I mentioned now. India will reduce the total projected carbon emission by 1 billion tons from now to 2030. Because India is aiming everything to be net zero by 2050, though our commitment is officially given for 2070, but our plan is much ahead. So that is the way we are going ahead with the plan. And let us come to the small state of Kerala. As you know that Kerala is a small state, not much industry. So you know that Kerala is only the kind of a emission is very less. the most of the emission is coming from the transport sector. So it is much easier to convert because if you go to EV, that is why the government has very strong EV plan and trying for that. Because that is one of the effective method for Kerala to come back because not many other things. So different states it will vary according to. So different states also have their own state climate action plan. So Kerala also have something called State Action Plan on Climate Change, which has been two versions, and the last one is came, and even they have given a proposal for 2023 to 2030. This is published by Department of Environment and Climate Change, and it's available in the website. So anybody can take and read. If somebody want, I can also send through mail. So it is state-specific climate change plan. Okay, then the Kerala target is about, because as I mentioned, the main sector is transport. If 100% energy mode by 2040, we can achieve much earlier. And it may be much easier for the state. Okay. And Kerala, some sectorial strategies in the report. Take summarized from that same report. Power sector, to expand the renewable energy capacity for by 3.46 uh, 2030. 5 lakh EV stations were planned. Industry efficiency in practice, and other industries were planned, and building like energy conservation building going to be in practice. Agricultural also they are planning to put a lot of energy efficient pump and are creation of. So like this, every state is planning for their state action plan. And finally, India government under MOFCC, they will have a national action plan. So a broader scale, what I mentioned, the climate change is global, but impact is local. We should have a local plan. So the last one is now I suggested is the implementation of this, because even mitigate, still subsidy will be there. That we have to live with. There you need the climate action plan. So that is what is government is discussing now. So you also have about the carbon I mentioned earlier, how we can. There are so many methods, which is one of the slide I have borrowed from this particular this set, how individuals can control their carbon footprint, either using like as a mass transport. There are certain things are maybe very to make it maybe or slowly practice it, like into then making efficient building. So little contribution we can also do. So PCC came up with the different almost suggestions of about 17 items which you can also read, which cover things like the aim is to get poverty, enough food, and health, education. So many aspects they have put. This is what is action plan of focusing it. Climate action plan is like they will put some goal and they make some strategy. So that is the way every implementation plan will be. And who is responsible for? As I mentioned in the beginning, each individual ones, all of us can protect our planet from our own little effort. Uh, so there are several guidelines which is web-based platform. When the ocean service and several places I have collected this. So you can also go through this, like the very famous 3R, that is reduce, reuse, recycle. That is anyway, that is even in Panchayat level, waste collection, reuse, recycle. It's all already in the stage, and many places it is practice as well. And the saving water, because even the water day programs, many awareness programs are also happening. You can do that, planting tree and the cement and the plastic awareness program. All those things will be our this one, but we individually, everyone can take some action, start from our house, we can also. With this, I would like to thank you all for your patience. If any-
Thank you, sir.
Yeah. Shall I?
Yeah, participants, if you have any questions, you can post that in chat box and we can mail the question. We have
Yeah.
the next resource person join.
So, any questions already?
No, sir.
How we can? Okay. There is one question. Maybe I don't know how we can. No. Okay. So he already got cleared himself. So
Yes.
okay. Anybody else has any question? Please ask. Or if you want to write to me, you can write me at my email. It is very easy. director@iccs.res.in. Okay. So we are engaged with, our institute is engaged with the all spectrum of climate change studies. We do have a strong group in atmospheric science, ocean science, and we have agricultural scientists, and we have geospatial analysis group, and we also have a good computational group. So with this, our aim is basically to support government for their policy formulation and also give scientific input to the government.
Thank you, sir. Thank you for the sessions.
Okay. Thank you. Thank you. If nobody has anything, maybe I may leave that talk now.
Yes, sir. Sure.
Okay.
Thank you.
Okay. Thank you. Thank you.
And
Good evening.
participants, next we have a session by Professor Juan Carlos from Poland.
Okay. Okay. So that may be starting now, is it?
Yes, sir. Yes, sir.
Okay. Please carry on. I will be taking off. Okay. Thank you.
Welcome, Dr. Juan Carlos. Am I audible to you?
Good afternoon. Good afternoon. Thank you so much for this invitation. And I would like just only to see how to share my presentation here. How I can understand. Okay.
You want to load the presentation, right?
No, I want to share the presentation from my screen.
Yes. Yes.
Yeah. How to do that? How to do that? Somebody is asking me to send the presentation. Yeah. How is the situation? I don't know what I have to do here.
You can share the screen and present.
How to share the screen, because I am not familiar with this Google system.
By the time you check, I'll just give an introduction, sir.
Yeah, I can go to my, maybe here. I don't know if it is so.